Alright, this is Physics 102, Exam 2, Spring 2016. What is the equivalent capacitance of this circuit? Well, I want to start with this one. This has 2 microfarads, a 2, a 1, and a 3. That's going to be 6 microfarads. So my equivalent circuit will be 3 and 6, this 3, and then this whole thing here is going to be 6. 2 plus 1 plus 3, and that's going to be 1 over 3 plus 1 over 6, which is equal to 2. So for number 1, the answer is 2. For the previous circuit, what is the voltage across the 1 microfarad capacitor? Let me clean this up just a little bit. So I want to know what is the voltage across that 1 microfarad capacitor. I need to realize that whatever voltage I have across this capacitor is going to be equivalent of the voltage across that 1 microfarad capacitor. So here I have 12 volts across these 3 and 6. The 6 is the equivalent of this whole parallel branch. And so whatever voltage I have across this 6 microfarad capacitor, I will also have across this one, and across these 2 capacitors. So if you know how your voltages are distributed, you can tell right off that this is going to be 4 volts and this is going to be 8 volts. If you're not certain of that, then you can say, well, the equivalent capacitance is equal to 2 microfarads, and so the charge on that equivalent capacitance will equal to 2 microfarads times 12 volts, or 24 microcoulombs. So I'm going to have on this 3 microfarad capacitor, I'll have 24 microcoulombs, and on the 6 microfarad capacitor, I will also have 24 microcoulombs because these are capacitors in series and they have the same charge. So then if I want to know the voltage is Q divided by C. 24 divided by 3, 24 divided by 6 is 4. So the answer is B for number 2. Number 3, what is the charge on the 6 microfarad capacitor? Well, gosh, we just had this, so a couple different ways you can do it. You can find the equivalent. The equivalent is equal to 2 microfarads, and so the charge is CV. 2 times 12 is 24 microcoulombs. So C is the right answer for 3. Which of these statements is necessarily true? The voltage across the voltmeter is very large. That is not necessarily true. It can be very large if the voltage that you're measuring is large, but it can also be very small if the voltage you're measuring is small. So not necessarily true. The current through a voltmeter is very small. That is true. The resistance of a voltmeter is very small. That's not true. In fact, the resistance of a voltmeter is very, very large. That's why you have such a small current going through it, because the resistance is so large. And a voltmeter should be connected in parallel. That is true. So 2 and 4. A is the right answer. Battery has an internal resistance of 1 ohm, provides a current of 2 amps. Potential across the battery is 10 volts. What is the ideal electromotive force provided by the battery? So if I think of my battery, if I were to represent it as a diagram, I would represent it as an EMF and an internal resistance. The internal resistance, we're told, is 1 ohm. There's nothing else here, but I know that it's providing a current of 2 amps. And so I know if it's 2 amps, I want to measure the potential across these 2 points, delta V. And I know that that delta V, which I'm told is 10 volts, is equal to the EMF minus I times R. So delta V here is 10 volts. That's my potential across the battery. E minus 2 amps times my resistance, which is 1 ohm. So if I solve that for the EMF, I get 10 plus 2, or 12 volts. So the answer, says number 5, is A. 3 volt potential difference is maintained across a 10 ohm resistor for 2 minutes. How many electrons pass through the material? Well, first you have to find the charge that passes through the material. Actually, first we have to find the current. So I is V over R. That's 3 over 10. 3 volts over 10 ohms. That's 0.3 amps. So that means I have 0.3 coulombs per second times 2 minutes, which is 120 seconds. What's that going to be? 36 coulombs. And then 36 coulombs, I want to convert that into electrons. So 36 coulombs, I would say 36 coulombs divided by 1.6 times 10 to the minus 19. Let's see what that is. It's either A or D. 2.25 times 10 to the 20th, so A is the right answer. This just tells you how many electrons make up this charge of 36 coulombs. So A is number 6. Consider this circuit. What is the current through the resistor? Oh, hopefully this was easy. So I have 12 volts. I want to know this current from Ohm's law. I is V over R. 12 divided by 3 is 4 amps. So D is 7. Flat iron is marked 120 volts, 600 watts. What is the resistance of this device? Okay, a couple of ways you could have done this. The easiest way, I know the voltage, I know the power, I know that P is V squared over R. So I just say 600 is 120 squared divided by R. So R is 120 squared over 600. And I get 24 ohms. So the resistance of that device is 24 ohms. Another way you could have done this, you recognize that P is equal to VI. I could have solved for the current. I'm looking for the resistance, I'm sorry. I could have solved for the current here. Let's say 600 is equal to 120 times I. So I here is 5 amps. And then I determine the resistance. R is V over I. R 120 divided by 5, which is going to be 24. In your house, 2 light bulbs operate at 120 volts, but one has a power rating of 25 watts, while the other has a power rating of 100 watts. Which has the greater current flowing through it? Well, the 100-watt bulb will. We can think about this a couple ways. P, well, no, let's just think about it in terms of the amount of energy. So the 100-watt bulb is putting out more energy, so it's going to have a greater current because you have more electrons carrying that energy. Or you can also think about it in this way. P is equal to V squared over R. Look, V is the constant for both of these. They both operate at 120 volts. So if P is big, that means that R is small. So the one with the smaller resistance, because of this relationship, if R is small, that means I is big. The one with the smaller resistance has the bigger current. The one with the smaller resistance has the bigger power. So the one with the most power, the 100 watt, has a higher current. So number 9 is B. All right, current flows through this wire. What is the resistivity select material? So a couple things we need to do first. I is V over R. Excuse me, not I is V over R. I need to figure out the resistance from Ohm's law. So I say R, V is equal to IR, so R is equal to V over I. So that's going to be V, which is 20 over 10, or 2 ohms. So I have 2 ohms for my resistance. And then I say, well, R is equal to rho L over A. And I solve this for rho, R A over L. 2, the area is given, 5 times 10 to the minus 8 meters squared divided by the length. It's 1 meter in length. And I solve now for my resistivity. Get 1 times 10 to the minus 7. But that's going to be iron here, this is equivalent to 10 times 10 to the minus 8. So number 10 is going to be iron. Number 10 is E. Consider this circuit. R1 has a voltage of 8 volts. What is the voltage of the battery? All right, so I have 8 volts here. Let's go ahead and figure out what is the equivalent of this thing. I have 6. These two combined to give me 3, and then I have 2. 1 over 6 plus 1 over 3 plus 1 over 2. What's that equal to? Let's see, that's 2, 6, 3, 6. 2, 3, 1, 6. Yeah, so that's equal to 1. 2, 3, and 6 in parallel is equal to 1 ohm. So my equivalent circuit would look like this. I have 4 ohms and 1 ohm, and I have some voltage here that I don't know, but I do know that the voltage across this is 8 volts, that means that my current through here is 2 amps. I have to have 2 amps to get 8 volts. So if I have 2 amps there, that means I'll have 2 volts here. 8 plus 2 will equal to 10 volts. So my answer is B for number 11. Which of these resistors has the smallest current? Well, let's think about it. My current comes along, all of it goes through that one, and then it splits up into 3 ways. And the one that will have the least current will be the one that has the branch that has the least current will have the highest resistance. This has 4, this has 1, these two combined have 6. So these two will have the least current of all. Let's see what my options are. R1, R2, R3, and R5. Well, it's definitely not R1, and R3 is listed, so that must be it. C is the right answer for number 12. Consider this circuit. What is the current through the 4 ohm resistor? Now you might be tempted to use a multi-loop thing here, and that would be okay, but it's a lot easier to look at this as a combination circuit. But be careful that you don't just draw a loop right here and say that it has to be, V over 12 over 14, because that's not right. Let's redraw this circuit just a little bit. There's my 10 ohm, and then it breaks into 2 parallel branches like this. So I have 12 volt, 10 ohm, 2 and 2 ohm, and 4 ohms here. And I want to know what is the current through that 4 ohm resistor. I need to continue on and find my equivalent. This is 4. 1 over a quarter plus a quarter here is going to be 2. So for this one, the equivalent is 2. So my equivalent circuit looks like this. I have my 10 ohm and a 2 ohm. 12 volts. So I have a current coming off here of 1 amp because I have 12 ohms as my equivalent. I is V over R, 12 over 12 is 1 amp. So if I have 1 amp coming there, that means I have 1 amp coming up through here. That means I have a voltage of 10 volts here, and the remaining voltage is going to be across these parallel branches. So I have 2 volts across each of these. That means, go to a different color here, that I'm going to have 2 volts here on that 4 ohm resistor, and so I can find my current across that is V over R, 2 over 4, which is equal to 0.5 amps. So A is 13. That was a bit difficult, although you've had circuits like this. Well, it's just sort of drawn a little bit differently than you normally see it. All right, let's see. So 13, now 14. Which of these statements about a household circuit is true? A household circuit is a parallel circuit. That's true. All devices operate at the same voltage. That's true. As you add more devices, the total current increases. Hey, that's true too. And a circuit breaker turns off if the total current exceeds some predetermined value. Gosh, that's true too. So E is the right answer for 14. Circuit breaker, you have these 3 devices. When you add a blender, it turns off. Which of these is the maximum allowed current? Well, let's just figure out the current. First of all, the current for electrical devices is going to be P over V. So for example, this first one, oops, sorry about that. This first one is going to be, clean this up just a little bit. So this first one is going to be 2400 over 120. So it carries, what's that, 20 amps. So I got 20 amps here. I've got 120 over 120, that's 1 amp. This is 2 amps. So initially I have 23 amps operating. And then I add this 360 watt blender, which is 3 amps, which brings me up to a total of 26 amps. So somewhere between 23 amps and 26 amps, it exceeds the maximum. And so I'm looking for a number between 23 and 26. B is the right answer for 15. What purpose does the GFCI serve? Not from too much current, not an alternate ground, A would be a circuit breaker. B is going to be that third prong. Turn off the circuit if the total current exceeds a safe value. No, that's not true either. D, protect the user from severe electrical shock. So yeah, 16 here is D. D is really the only appropriate answer. You could also say that the GFCI turns off if uh, I in exceeds I out. We talked about that in class. All right, which of these rules for resistors in parallel is correct? Resistors in parallel must have the same current. That is not true. Resistors in parallel must have the same voltage. That is true, so 2 is correct. Gets rid of these two. For resistors in parallel, the total voltage across the resistors is equal to the sum of the voltage across the individual resistors. That would be true for series, but it's not true for parallel. And the equivalent resistance is always less than the smallest resistor. That is true. So 2 and 4, C for 17. Which of these plots show the voltage versus time for a charging capacitor? Well, remember, our voltage is going to start out really small and then it will plateau to a certain level. So the only one here that matches that is going to be B, and it will max out at a value that's equivalent to the voltage of my battery. So B. Consider an RC circuit for which R is a mega ohm, C is 5 microfarads, and E is 10 volts. No charge. What is the charge after 5 seconds? So actually here I just need to take a break for a quick sec. All right, so I'm looking for the charge on this at a particular time. Don't forget your equation sheet. So you can go here and you can look for the appropriate expression. Here I'm looking at the charge of a capacitor when it's charging. So Q is going to equal to that 1 minus e to the minus t over RC. Oh, and then this is going to times our Q max, which is going to be equal to C times V. So it's going to look like this. Q is going to equal to CV, 5 times 10, so 50 microcoulombs, times 1 minus e to the minus t, which is 5 seconds, over RC. RC is our time constant, and that's equal to 1 megohm, 5 microfarads, which is 5 seconds. So that's e to the minus 1. So this works out to be, for number 19, D is the right answer, 30. Notice, by the way, that I could get rid of several answers. I could get rid of this answer. I could get rid of this answer because that's the maximum it can be is 50. I could also get rid of this one. The charge will approach 0 but not actually reach it. Okay? Certainly not after 5 seconds. Well, we would say that it has 0 coulombs of charge after a time of 50 seconds, which is a time of 10 time constants. Which of these rules for resistors in series is not correct? Resistors in series must have the same current. Not correct. They might have the same current if they're the same resistor. Resistors in, or no, I'm sorry, that is correct. They must always have the same current. So that is correct. They might have the same voltage, but only if they're identical. They have to have the same current. They might have the same voltage. For resistors in series, the total voltage across the resistors is equal to the sum of the voltage across the individual resistors. Yeah, that's true. For resistors in series, the equivalent is equal to the sum of the individual resistors. That's true too. So I'm looking for 1, 3, and 4. Let's see, number 20. Oh, I'm looking for ones that are not correct. I'll make sure that we have a point there. So number 20 I'll take a look at, but I might change it. But the answer here is the one that is not correct is 2 only. 3 resistors are in series with a 36 volt battery, 2, 4, and 6 ohms. What is the potential across a 6 ohm resistor? So 36 volts, 2, 4, 6 ohms. That gives me an equivalent of 12 ohms if I add those together. That means that I have a current here of 3 amps. So if I'm looking for the potential across this 6 ohm resistor, it's just going to be 3 times 6 or 18 volts. D is 21. Which equation is correct? All right, so let's see. I'm going to zoom out just a little bit so we can See all of them? 3 minus 2I1, that's starting here and going in this direction. So far, so good, going with the current. Plus 6 minus 6I2. Yeah, see now this is not a closed loop, so it can't be that one because it doesn't do a closed loop. So A is not the right answer. 3 plus 2I1. Oop, that's not right. It should be minus 2I1. Plus 5, that's correct. That's correct. Everything's correct there except for the sign. I1 plus I2 plus I3 is equal to 0. Well, let's just pick a junction. I have I1 coming in, I2 going in, I3 going out, so that's not right. Hopefully this last one is right, huh? 5 plus 6I2 minus 6. 5 going in this direction, plus 6I2. That's right, I'm going against the current. Minus 6. Oh, that's the winner, so D is the right answer for 22. For the circuit above, what is the direction and magnitude of I2? Okay, well, so the key here is that we use the right equation. I want to know the current through this resistor. I want to know this current. And I could use the top loop to find it, but notice that I have a resistor here, and so that would bring I1 into the equation. So I'm going to use the bottom loop. Oh, and look, I already have the equation there, so I'm just going to use that equation. 5 plus 6I2 minus 6 equals 0. So I2 equals 1/6, right? Yeah, 1/6 amp. And it's positive, so it should be as it's drawn, so that is to the left, so D is the right answer. What is the current through the 2 ohm resistor? Well, this is similar to the one previously, but here I need to label my currents. So I'm going to say that this current goes in this direction. I'll call this I1, and then that's really the only current I need to recognize, but do recognize that there is a current through this path, and that is a different current than what I1 is. But since there are no resistors in this part, that current doesn't come up. So I can just erase this because it's actually not important to my question. So let's go in this direction. I have minus 12 minus 2I1 plus 6 equals 0. So I1 is equal to 6 divided by -2 or -3. So it should be 3 amps. And actually the current is not going to be going down, it's going to be going up. That's why it came out negative. So 24 is B. Measure the voltage of 4 volts across 2 ohm resistor in 2 minutes. How much charge is passed through the resistor? Well, we had a similar question to this before, but I is equal to V over R, 4 over 2. That's equal to 2 amps. So I have 2 amps in 2 minutes. How much charge? Well, 2 amps is 2 coulombs per second times 120 seconds. That's 240 coulombs. So D for 25. And let's see, what was this answer? Mia Roberts. I don't know Mia Roberts. No, it can't be that one. Jacques Richard. I don't know who that is. Ayana Clarare. She has a funny name. Joseph told, oh, Joseph. Yeah, he was a good student, but it's not him. It's you. You nut. All right, so anyway, that's the end of the exam. Here are the answers